One of the most frustrating parts of the gas laws for general chemistry students is feeling like you have to memorize a giant list of equations. Boyle's law, Charles's law, Gay-Lussac's law, the combined gas law, Avogadro's law. And students often try to memorize all of them separately. But here's the good news. You actually do not need to memorize all of these equations individually. Almost every gas law in general chemistry can be derived directly from one master equation, the ideal gas law. PV equals nRT. Once you understand how to rearrange this equation and determine which variables stay constant, you can rebuild the gas laws anytime you need them. That means less memorization and more understanding. In this video, we are going to learn how all the major gas laws come directly from the ideal gas law equation. The key idea is this. If a variable stays constant, we can essentially remove it from the equation and move the changing variables to the same side to see their relationship. Then we compare the initial state, which we call state 1, to the final state, which we call state 2. This gives us the familiar gas law equations automatically. Let's start with Boyle's law. Boyle's law describes the relationship between pressure and volume when the number of moles and temperature stay constant. So if N, R, and T are constant, we can remove them from the ideal gas law. That leaves pressure and volume together. We compare the initial state and final state and get P1V1 equals P2V2. This is Boyle's law. Notice we did not memorize it, we derived it from the ideal gas law. Boyle's law tells us pressure and volume are inversely related. If volume decreases, pressure increases. Now let's do an example. A gas has a pressure of 1.2 atmospheres and a volume of 4.0 liters. The gas is compressed to a volume of 2.0 liters. What is the new pressure? First, identify the variables. P1 equals 1.2 atmospheres, V1 equals 4.0 liters, V2 equals 2.0 liters. We are solving for P2. Now plug everything into Boyle's law. 1.2 multiplied by 4.0 equals P2 multiplied by 2.0. Solving gives a final pressure of 2.4 atmospheres. Now let's move to Charles's law. Charles's law describes the relationship between volume and temperature when pressure and moles stay constant. This time, pressure, moles, and R are constant. That leaves volume and temperature. Comparing state 1 and state 2 gives V1 divided by T1 equals V2 divided by T2. This is Charles's law. Again, we did not memorize it separately. We derived it from the ideal gas law. Volume and temperature are directly related. As temperature increases, volume increases. One very important reminder is that temperature must always be in Kelvin for gas law calculations. Let's look at an example. A gas occupies 3.0 liters at 300 Kelvin. It is heated to 450 Kelvin. What is the new volume? Identify the variables. V1 equals 3.0 liters, T1 equals 300 Kelvin, T2 equals 450 Kelvin. Solve for V2. Set up the equation. 3.0 divided by 300 equals V2 divided by 450. Solving gives a final volume of 4.5 liters. Next is Gay-Lussac's law. This law describes the relationship between pressure and temperature when volume and moles stay constant. If V, N, and R stay constant, we are left with pressure and temperature. Comparing state 1 and state 2 gives P1 divided by T1 equals P2 divided by T2. Again, no memorization needed. Pressure and temperature are directly related. As temperature increases, pressure increases. Here is an example. A gas has a pressure of 1.5 atmospheres at 250 Kelvin. The gas is heated to 500 Kelvin. What is the new pressure? Identify the variables. P1 equals 1.5 atmospheres, T1 equals 250 Kelvin, T2 equals 500 Kelvin. Solve for P2. Set up the equation. 1.5 divided by 250 equals P2 divided by 500. Solving gives a final pressure of 3.0 atmospheres. Now let's discuss Avogadro's law. Avogadro's law relates volume in moles when pressure and temperature stay constant. If pressure, temperature, and R are constant, we are left with volume in moles. Comparing the two states gives V1 divided by N1 equals V2 divided by N2. This tells us volume and moles are directly related. As the number of moles increases, volume increases. Here is an example. A gas occupies 2.0 liters with 0.50 moles of gas. If the amount increases to 1.0 mole, what is the new volume? Identify the variables. V1 equals 2.0 liters, N1 equals 0.50 moles, N2 equals 1.0 mole. Solve for V2. Set up the equation. 2.0 divided by 0.50 equals V2 divided by 1.0. Solving gives a final volume of 4.0 liters. Finally, if pressure, volume, and temperature are all changing while moles stay constant, we combine everything together into the combined gas law. P1V1 divided by T1 equals P2V2 divided by T2. And once again, this equation comes directly from the ideal gas law. So instead of trying to memorize 5 separate equations, focus on understanding the ideal gas law and determining which variables stay constant. Then you can rebuild any gas law whenever you need it. That approach is faster, more logical, and much easier to remember during exams.